Science genuinely has the ability to transform the competitiveness and the profitability of farm businesses in the UK.
As we improve farm communications, as we improve data capturing tools, farming is going to change dramatically.
I think in the next 30 years, the advances that we see in genetic improvement, in the use of big data, data-driven technologies, and also understanding farm systems is where we're really going to see the step changes and the transformation in agricultural production.
And if we utilise these technologies, then we've got the ability to make the whole crop production system significantly more efficient than it is now.
It's the way things got to go, to keep competitive. Lots of new things to think about, lots of new ideas and technology around the corner.
Instead of using dumb machines, we can use smart machines, and those smart machines can then help us to achieve what we all want: cheap, efficient, good quality, low impact food. We've developed a robot strawberry harvesting system that not only picks the strawberries but also grades the strawberries at the point of harvest. Another project we're running is the hands-free hectare, which is where we then grow a complete cycle of a crop, in this case barley, in 1 hectare without anybody ever going in that hectare. The machines are in the field running by themselves.
The future of the UK aquaculture industry is going to be entirely dependent on innovation. With the increasing global population and the rapidly increasing demand for seafood, the use of modern genetic testing is becoming absolutely essential to drive steady trait gains and to prevent inbreeding. So by 2050, we expect to see modern genetic techniques being used in the UK by the major salmon farming companies, new companies coming into existence, older companies switching to genetics for the first time.
Here at the Earlham Institute, we're looking at different ways that new technologies can help farmers so that they can make a sound decision about the timing of chemical applications and irrigation. Nearly everyone is flying UAVs and drones nowadays. However, how to extract meaningful information from these data is the current bottleneck. And what we are doing is to utilize the latest image analysis as well as machine learning algorithms and then generating a warning message triggering system, which means that if the crops is under stress, that will trigger a warning message, which means that farmers need to do something for their crops.
We're currently witnessing in agriculture a new data revolution. Connectivity is the holy grail. We've been working with some satellite companies to try and develop a new wireless technology solution so that farmers can have connected tractors and sensors in fields that are connected to the internet 24 hours a day. That will allow us a whole opportunity to start looking at how we can connect vehicles, transfer data and support people in ways that we could only dream of today.
If we can achieve a genuine partnership between the farming community and the science community, we have the potential to transform the profitability and competitiveness of farming businesses in the UK.
Aquaculture around the world is worth $150 billion. Only 10% of this is currently using modern genetic tools to manage the breeding programs. And there's a vast opportunity around the world.
And from the data revolution, I'm convinced we're going to see a new engineering revolution, potentially allowing us to change our whole cropping systems.
Agricultural robots will have a worldwide impact to make the whole crop production system significantly more efficient. And that's good for economics, that's good for sustainability, it's good for society.